To begin part 2 of our Module 5, Lesson 6, we're going to do a warm-up again. It's all about word problems for the next couple of days. On page 4 of your practice tests, 21 and 22 are on this. We're going to do 21 together. I know I usually like to let you try it first, but I'd like to show you an example of how I set it up, and then when we do 22 on the next video, you can do it all by yourself first. Okay, 20 pets were rescued, and it looks like we just have dogs and cats. So what I write after reading that is this, and a lot of students kind of just fly right past that and don't realize that is the key to the problem, that there were 20 pets. And remember how we talked about the rope? If the rope is 9 feet long and one part of it's X, the other part's 9 minus X, this is that kind of problem. How do I know? Because they gave me a total. So if the number of dogs rescued is D, write an expression to represent the number of cats that were rescued. So I can actually use this equation that I got from reading this. Dogs plus cats equals 20, and it says use little d, so I can change that to little d to match theirs to represent cats. In other words, they're asking me to solve for cats. And my answer should have a D in it, which it will. Because when I'm solving for C, I move everything else to the other side. So, subtract D, so I can see cats equals 20 minus D, which we already knew. We learned that with the rope problem. If the rope was 9 feet long, and I called one of them X, or in this case D, the other part was 20 minus D. So that's the number of cats. The number of dogs is D. And if you want to write it out in words, I kind of like to write it in words just to get used to doing that. And 20 minus D is the number of cats. And it comes from that very first sentence that so many people, because it's not a number written out, it's written in words, they just skim right over that key to the whole problem. So that says dogs plus cats equal 20. Well, they told us to call dogs D, which we did, and then they said to write an expression for cats. That's another way of saying solve for cats. Minus D, so the number of cats is 20 minus D. So anytime you're given a total, there's always going to be one that's X and the other one that's the total minus X, or in this case D. At the end of the rescues on Saturday, a total of $931 had been collected. all 20 animals. Write an equation in terms of D that can be used to solve to find how many dogs and how many cats. Well, that's where this box comes in, because the minute I see money, I know I can't just use these. I need money involved. So the equation would be $55 for every dog plus $42 for every cat equals $931. So 55 times the number of dogs plus $42 times the number of cats gave me a total profit of $931. And then we just have a nice simple little equation to solve there. And it might be a really good idea to put your variables down here so that when you do find D, you know how to fill in the blanks for each of these. So we know D is the number of dogs, and we know 20 minus D is the number of cats. Because that'll make it quicker when you get D equals 10 to put 10 there and 10 there and find your two answers. So we have 55D plus 42 times 2 is 84 with a 0, so that would be 840 minus 42D equals 931. So we have some like terms over here. And what's that going to leave us? 13. 5 minus 4 is 1. 5 minus 2 is 3. So 13D plus 840 equals 931. Two-step problem. Bring your constants to the right. And then last, divide by 13. So 931 minus 840. 931 minus 840 is 91. Divide both sides by 13. And remember, don't be doing mindless math. Before you even find this answer, you should know what D is. D is dogs. So this is going to tell us how many dogs were rescued. That's why we use D instead of a random X or Y. And last step, 91 divided by 13. 91's already there, so divide by 13. That gives us 7. So now we know 7 dogs were rescued. And then this is also 7. Remember, every D in the problem now has a value of 7. This one has 7. 20 minus 7 is 13 cats. And you can easily see they add to 20. We're all good. So, big fun fact there is that writing that right at the beginning, just like when you do this one on the next one, you're going to write A plus C equals 68. That's how you're going to start it. A plus C equals 68, and then go from there. But we're going to do that on the next video. So that way you have one under your belt. Okay, everybody get that down. Okay, let's go to page 2. Just have a couple of problems on that. This might be a little bit shorter video, I think. Short is good, right? The value of most assets, and this is page 2 of Module 5, Lesson 6. So page 2, we had just completed page 1. It's a 4-page section. We just completed page 1 in the last video. So most assets like cars, computers, depreciate or drop over time. So right away when I see the word depreciate or the word drop, I know that that means there's going to be a subtraction in my problem. Depreciate means the value's going down, so I know there's going to be subtraction. So that's the first thing that goes through my mind when I read that first sentence. When an asset depreciates by a fixed amount per year, we call that straight line depreciation. So suppose a car has an initial value of $12,400 and it depreciates $800 per year. So it's telling us right here that years are T. So there's your equation. 12,400 minus 820T. Direct translation. As long as you know depreciates means the value's going down. Appreciates means the value's going up, like the value of a home. But cars and computers and things like that generally are going down. So write an expression, 12,400 minus 820, and they told us to use T in place of years. So you didn't realize how valuable that translation stuff was until you got to these word problems, right? Isn't it amazing how easy they are after you learn how to translate? How long will it take for the value of the car to decrease to 2,000? Solve the equation, state your answer in a complete sentence. So this is the value of the car. So when will the value of the car be 2,000? So the value of the car, and we could have even written that here just to remind ourselves that's the expression for the value. It's also written here. So the value will be $2,000. And then just a simple little algebra equation to solve. So negative 12,400 needs to move to the left. Negative 12,400. Because T's on the left, numbers on the right. And I think I just said move 12,400 to the left. I meant to the right. Sorry, it's getting late. Negative 820T equals, I think that's going to be negative 10,400, but we'll verify. 2,000 minus 12,400. Negative 10,400. And then last but not least, we divide each side by negative 820T. Because we know this answer has to be positive because it says how long, so you can't get a negative number of years. So positives on both sides, so T equals 10,400 divided by, I'm just going to, since it said negative, I'm going to divide by negative 820 just so the answer comes out positive. I hate it when they don't tell you to round. Who made this packet anyway? Jeepers. Doesn't say. Let's see what it looks like as a fraction. Second fraction to decimal. That's not much better, is it? Second fraction to decimal, so I guess we're going to have to do approximately. I wonder if there were directions at the top of the front page that said, somebody must not know the rules for rounding, whoever wrote this. Like I said, the different schools did these, you know, like Scottsdale did one of them, and Chandler Gilbert did one module, and so I feel like Chandler Gilbert did this one, but they should have a rounding statement. So I guess we're going to have to just approximately 12.7 years. Because we know T is years from up here. And you always label your answer because that is what's going to help you write your sentence. The car's value will be $2,000 in approximately 12.7 years. You don't label that and you'll have no idea. You'll be like, oh, how am I going to write a sentence for that? But the minute you put the label on it, boom, piece of cake. So the car's value will be $2,000 in approximately 12.7 years. Okay. So that's not so bad, huh? I also put that one on the test. I love that problem. Very nice problem. I don't like how it turned out without a rounding feature on it, but I can easily change that in Alex. Okay, let's see what we have next. In 2008, the housing market had a dramatic change because most houses experienced a decrease in value. This is why I got my house for so cheap. I bought it in 2012, right when they were starting to get up, so I got a house for $200,000, and now it's worth $600,000. What is that, 13 years later? And that was dumb luck because I knew nothing about the market, but this is a true little problem here. So 2008, we had that little decline in our, I don't know, what did they call it? Why am I not thinking of it? Kind of a depression, but it wasn't that. There's some name. So then the housing prices started increasing in 2012. Suppose you bought a house for $130,000 in 2012 and it has steadily increased. So I know this problem, instead of having a subtraction, is going to have addition by $35,000 a year. And it looks like year is going to be Y. Represent the market value in dollars for your home, and Y, the length of time you have lived there in years. Okay, so let's first write an expression, because you can't fill in the table till you write an expression. Write an equation that expresses the value V of the market value after living there for Y years. So the value is, and then we do our direct translation, 130,000 increases plus 3,500 per year, and they told us year was Y. So exact same as the problem we just did, but instead of depreciating and putting a minus there, we're appreciating or increasing, we have a plus. So the house's value is 130,000 plus 3,500 going up per year. Write an equation. Okay, so we got that done. So now we can do this. So in 2012, 130,000. So that would be considered year zero, right? Do you guys know that? So the beginning price in year, that's called year zero. Because if I put a 1 here, that would say in 2012, it was worth 133,000, and it wasn't. I need this to be a 0, so this goes away, and in 2012, my house was worth $130,000. (2015), how you find what year it is you take 2015 minus year 0. So that means that is year 3. So I can use this equation to get the value. So the value is 130,000 plus 3,500 times 3. Since both of these are going to use a calculator, let's write them both out and then we'll do them at the same time. 2018, to find out what year it is, you take the year minus year 0, and that would be 6. So to find this value, it would be 130,000 plus 3,500 times 6. Okay, I think we're ready for the calculator. So in 2015, the house is going to be 130. Whoops, accidentally hit a decimal place there. 0, 0, 0. So there's 130,000 plus 3,500 times 3. And that's going to be 140,500 will be the value after living in the house for 3 years. Now let's see what its new value will be after 6 years. So want to see a cool feature on the calculator? Love this. I always teach this during the calculator workshop. So hit the up arrow and it brings back the last line you typed, and key over using the right arrow key and just change the 3 to a 6, and I don't have to type it again. Yes! Isn't that a cool feature? So hitting the up arrow produces the last line you typed, and you can change any part of it. So if you see that you typed it wrong, or you want to change a number like I did, I wanted to change 3 to 6, just type it right over the top and hit enter. Beautiful little calculator. So 151000. Okay, so we completed the table. We wrote an equation. Now let's see what the last sentence is about. In what year is your home expected to be this? Oh, tables are changing there. So we've been plugging in for Y, because Y is the number of years, but this is the value. So it's going to go right there. And that's why we use letters that talk about what we're doing. Then you don't have to go, oh, this is an X, this is a Y. What do they mean? I know Y is years and I know V is value. So they give me the value, boom. So our new equation is going to be 186,000 equals 130,000 plus 3,500Y. And I'm going to turn this baby right around because I like having my Y on the right and up front. So 3,500Y plus 130,000 equals 186,000. Anything without a Y moves right, so subtract 130,000, subtract 130,000, and that leaves us with 3,500Y equals 56000. So 0, 0, 0. This is a 6. 8 minus 3 is 5. The ones are gone. And let's see what kind of cockamamie number we're going to have on this one. I'm guessing the same person made this whole worksheet, so it's going to be some other weirdo number. So 56,000, dividing both sides by 3,500. Divided by 3,500. Ha! Just when I started complaining, they gave us a nice whole number. So we have Y equals 16, and I don't even have to guess what Y is because Y is years. That's why we picked Y. So if we had to write a full sentence, in 16 years, the home's value will be 186,000. And we might as well write it since they had us for other ones. So in 16 years, prepositional phrase, put your comma, the home's value will be $186,000. Or you could say the home's value will be 186,000 in 16 years. Order doesn't matter. So either way is fine. And there you have it. So page 2 done. Okay, we'll start the next video with a warm up from the practice test, and then we'll do page 3. See you in a bit.